this short video is about line balance, specifically 3 measures to know whether you've got a good or a bad line balance and whether it's improving the right way. To do that, I'm going to put an example up here and run through the actual metrics so you can see exactly how it's done, and then you can apply it to your own area. So this is a line balance chart that I've drawn for 5 operators. You can see operators 1 to 5 across the x-axis, and time in seconds, the cycle time, floor to floor cycle time, is up the y-axis. You can see from videoing or stop watching a number of cycles, number 1 operator has got 32 seconds, number 2 22, 38, 20, 24. You can see their cycle times. And then across the top we've got the takt time, how fast we have to go, how often a part has to come off the end of the line. We've got all the data we need here to assess whether this is a good line balance or not. But there are 3 metrics. So the first metric is to look at how fair the balance is. We're going to call this line balance ratio. And this is concerned with fairness. How fair is the balance? Okay. To do that, we take the sum of the cycle times and we divide it by the longest operator multiplied by the number of operators. So in our example, the sum of the cycle times is 136 seconds. The longest operator is 38 seconds, and there are 5 of them. If you do the maths on that, that's 136, 40 over 190, 72% line balance ratio. Higher is better with this. 100% is perfect, a perfect balance. This is fairness, this is for your operators. However, if that was 100%, it could be 100% with all of those down at 5 seconds. So clearly we're missing something because there'd be a big gap to efficiency there. So line balance ratio can't be the whole picture. There is a second measure called line balance efficiency. Again, expressed as a percentage, and this looks at how efficient your balance is. Essentially how close to takt time you are. And this is the sum of the cycle times again over takt time times by the number of operators. So in this case it's 136 seconds if you add up the times again. Takt time is 40 seconds from our picture times 5 gives you 136 over 200. As a percentage, that is 68% line balance efficiency. A perfect balance would be 100% line balance efficiency, but a word of warning here, you don't want to get to 100%. Because each operator would be right up against takt time. There's no allowance there for losses, quality, productivity or availability. Whether you've got a machining related line or whether it's just manual assembly, you need to allow a gap between the top of the cycle time and takt time. And the third metric, which is often the killer metric, but one we have to be a little bit careful with, is Optimum Manning. Now Optimum Manning tells you with a following wind, with no issues, how many people you need online. So you know at the moment we have 5 people, and this is literally the sum of the cycle times over the takt time. Sum of the cycle times is still 136, the takt time is still 40, and if you do the maths on that, that comes out at 3.4 people. And you can see from our current that we've got 5 people, so we're notionally 1.6 too many. But a couple of things to bear in mind here. Firstly, you can't have half a person, so you have to work out what to do with that half a person, and ideally it would be some other value-added activity, something like sub-assembly, or maybe doing the 5S for the line, or quality checks, or replenishing or something. More to the point, this assumes that there are no problems, and there are always problems. So Optimum Manning, be careful, it's indicative. However, all the waste is still baked in there. So these cycle times that we had are before we've taken waste out. There you have the 3 metrics to know whether you are improving your line balance. Your after metrics, after you've rebalanced, should be higher, higher, smaller. Otherwise you're going the wrong way.